Hey, grade nines. Welcome to your next lesson. We've basically almost wrapped up the course. We've only got two more topics left, maybe three, depending on how we do with time. The next one we're going to look at is probability and statistics. This unit's a lot of fun. It's a bit of a different one because we don't do as much numerical math. Like we do a little bit, but some of it is more of logical reasoning, thinking, and answering in words. We'll do some examples as we go along, and you'll realize that it's a slightly different unit. Probability is essentially the math behind things like chance. So what are the odds of something happening? If I say there's a 100% chance that the Earth is round, what does that mean, right? That's what we're going to be looking at in this unit. So before we jump into anything, let's get some definitions down. One of the things to start off with is a way that you can state probability. There's three different ways that you're going to be able to do that. One of them is like a percent. So if we're looking at 70%, that would look like, not 70 with the percent symbol. You can also write it as a decimal. So a decimal is when you take that percentage and you divide by 100, you end up getting 0.70, because that's 70%, or just 0.7. Both of these probabilities are exactly the same thing. The third way is to state a reduced fraction. I've reduced in square brackets because sometimes your fractions will not be reduced. It's your job to figure out how to do that. So if you're not comfortable dealing with reduced fractions, you might want to avoid that when you're recording your responses, but I will be making you practice it a little bit. An example in this case is because I have 70% or 0.70. Remember, to get from 70 to 0.70, I divided by 100. So it looks like this. 70 over 100, however, is not a reduced fraction. I have to divide both by 10 because I can still do that. And 7 out of 10 would be my reduced fraction. So three ways. These are all three ways of writing 70% or 7 out of 10 or 0.7 of a chance. These are all different ways of writing that. Another thing to keep in mind is that when you're dealing with probabilities, they should always all add up to 100% if you're dealing with percents, or 1 if you're dealing with a decimal or a reduced fraction. So in this case here, I have 70%. Which means that there should also be a probability of 30%. If we add both together, we get 100%. As a decimal, I have 0.70 or 0.7, which means there should also be a probability of 0.30 or 0.3, because that will add up to 1. And for my fraction here, I have 7 over 10. So the only way that I can have a full probability is if I have another fraction, which is 3 over 10, and that's the remainder probability. Once we know how to record different types of probabilities, we need to understand what kind of probability we're dealing with. There's three different types that we're going to look at. One of them is called theoretical probability. So theoretical probability is based on statistics alone. And an example of that is if you're flipping a coin, right? A coin has two outcomes, heads or tails. If I flip a coin, I'm looking for heads. There's a 50% chance that I'm going to get heads. And that's because the theoretical probability of getting heads is 50%. Next, we look at experimental probability. So this is based on a number of trials that you will have to do to determine what the probability is. If we use the coin example again, if you flipped a coin 10 times, it's possible that 7 of those 10 times you end up getting heads. Experimentally, your probability is telling us that there's a 7 out of 10 chance you're going to score heads. 70% of the time you're going to get heads when you flip a coin. We know that's not theoretically true, but clearly it happened. That's your experimental probability. The third thing to consider is subjective judgment. So this is a personal assumption that you're making based on some experience you had to rationalize a probability. If you're playing a game with someone, for example, where you're flipping a coin, and you would win if the coin lands on tails, the other person wins if it lands on heads. Well, in the last situation, it landed on heads 7 times. So you might rationalize, you know what, maybe the tail side is heavier, so it's being pulled to the ground more, and that's why heads more often faces upwards. That's a wrong statement, but I might conclude that because I'm making a subjective judgment. Part of probability and statistics and analyzing this probability and statistics is recognizing when there's subjective judgment and whether that's influencing our analysis or not. And it's a good habit to take a step back and look at your own bias when you make a statement. Not just in math or not just in probability, but when you say something yourself, do you have subjective judgment? Do you have bias? Yes. Is that influencing your result? Preferably not, especially in probability and statistics. So make sure you recognize when that's the case.